So, hi students. Today we can start over next topic, that is the Bais Variance Tradeoff, which is the most important topic in the machine learning. So we can start over this session with the Bais Variance Tradeoff. So I hope you already know about your gate syllabus of the DA, and we have already finished multiple things in the previous few lectures. So here we need to be proceed after this. We have in our previous lectures completed till decision tree. So this video contains this particular section, that is a Bais Variance Tradeoff. Okay, so what exactly the bias, what exactly the variance, and what is the trade-off meanings in the machine learning, we need to be understand in this particular session. Let's proceed further. So these are the reference books. You can proceed in this with this reference books that if any required, then you can go with these types of books where MIT Press books is the most commonly used, and the NPTEL IIT Guwahati concepts of machine learning, you can proceed with that. Now come to the basic thing, that what is a bias and what is a variance and what is a trade-off. So before moving further, you must have to be understand that what exactly the meaning of the trade-off and the bias and the variance. So just simple understand the thing. A most common term which is used in the machine learning is the generalization. Okay, that is generalization of a model. So all these Bais variance trade-off is mainly related to your generalization of your model. Keep in the mind that certain things, that something is high, something is low, maybe something A is low and B is high. In that case, you need to make a balance between that. So this complete concept, Bais variance trade-off, is all about that, making the balance of all these things, that how can you generalize your model and how the bias and the variance can be balanced. In the complete session we can see. So Bais variance trade-off, what it is nothing but it is a foundation of model generalization. I have highlighted this term, that you have to be understand that it is nothing but the model generalization, foundation of model generalization. Then whenever you need to go with your model, then Bais variance trade-off is nothing but it is a foundation or a concept which basically relate to the model generalization. Whenever I'm saying that generalization, so what exactly the generalization means? Good generalization means good performance on unseen data. See, whenever you can feed a particular data to your machine learning model, it can provide you a particular result. So when you provide the unseen data which is not given earlier to your model, then how your particular model will be generalized to that, how your particular give the output for that particular data set. This is the mainly known as a generalization, that is everything is generalized. Keep in the mind, for example, I am making a machine learning model which is generalized to all the disease which is occurred due to the fatty liver. Okay, so if I'm saying that fatty liver, maybe this is diabetes, maybe it is BP, maybe it is sugar, maybe it is heart attack, epilepsy, any other etc, lots of disease which can be caused due to the fatty livers or the obesity and all these things. Then how you can make a particular model, a generalized model who can detect all these disease. Okay, so this can be done by the generalized model. Okay, so make your model more generalized, you must have to know the concept of the what is a bias and what is a variance, and what are the different characteristics and the factors which can be which influence your bias as well as your variance. So let's start your particular concept, that what is Bais variance trade-off. First, before proceeding further, you must have to think in the mind that it is a basic concept of the foundation of model generalization. Okay, whenever a term I have used further also, if I'm using model generalization, then what exactly it means, that good generalization means good performance on unseen data. Okay, if any new data will become or any unseen data will become to your particular model, then how your particular model react to that particular data, that is known your generalized model. Okay, let's proceed further. So a good machine learning model should learn meaningful patterns. Keep that in mind. These are the characteristics. If I'm saying that it is a good machine learning model, then what it is learn meaningful patterns, avoid memorizing the noises. Okay, any memorizing noises will be there, it must have to be avoid them. Perform well on the unseen data, again a term which is most commonly used and again I'm using is the unseen data. Okay, so it can perform well on the unseen data as well. Next, the optimal models. What the meaning of optimal model? That is, it is unfitting, lies between the unfitting, which is your high bias, as well as overfitting, which is your high variance. I hope in the previous videos also I have discussed multiple times that what is a overfitting and what is a underfitting, what is the concept of biasing and what is the concept of the variance. So if you have not viewed that particular video, you can just go on my playlist session of this particular ML series and you can go and watch that particular overfitting and the underfitting concept. And I hope by that particular 20-minute video you can easily understand that what is the underfitting and what is the overfitting. From here we need to be understand only a single thing, that under the underfitting part your bias is so high, under your overfitting part your variance is so high. Okay, again and again two terms come into your picture multiple times, that bias and the variance, bias and the variance. Then what exactly the bias and what exactly the variance we can see in the upcoming slides. Now this balance is achieved using how you can achieve this particular balance? Proper model selection. Since you will find that high underfitting, high variance, high bias will be there, then how you can achieve that particular balance? That can be achieved by your proper model selection, can be achieved by regularization technique. I hope L1, L2 regularization we have already studied in the lecture number 6 or 7. Again, you can see that particular video if you have not studied that. So regularization techniques we have seen. So how that particular balance can be achieved? By the model proper selection. Second, your regularization. Third is the cross validation part. Fifth is the sufficient data and the ensemble learning. These are the few segments through which you can balance your particular model. Now, Bais variance trade-off, what exactly it is and what is the mathematical intuition behind that? So, a Bais variance trade-off explains why some model can underfit the data, why some model can underfit the data while other overfit the data. Okay, sometimes your particular model can underfit your data and sometimes that particular model will overfit that particular data. So what you need to be do, you need to be achieve a balance between them. So your goal of machine learning is to build the model that gives generalized well to unseen data. Okay, your model must be generalized and can easily predict the things in the unseen data. So a model prediction error you can calculate and can generally be decomposed into that your total error will be equals to the Bayes square plus variance plus irreducible error. Irreducible errors are those errors which cannot be eliminated. I hope you already know that errors are of two types, which are reducible and few are the irreducible. They can be must be present in the your model due to some certain noises. Okay, so that's why these are unreducible error. A basic mathematical intuition we have written here. What it is exactly we can understand in detail in the upcoming slide. Don't worry about that. That first, that is your total error. Since your model is not generalized, your model is overfit or the underfit your particular data. That's why there may be certain error and that particular total error will be nothing but your Bayes square plus variance plus irreducible errors will be there. Moving further, what exactly the bias and what exactly the variance? Sometimes we have studied multiple things, but you are unable to understand the basic concept that what is a bias and what is a variance. So we have added few slides here for understanding you, give you understanding about the bias as well as the variance. Since we have already studied this formula, Bayes square plus variance plus irreducible area error, but still most of the students are unable to understand the basic of bias as well as the variance. So first we can clear that particular thing, that what is a bias and what is a variance. Then we can understand again that what is a trade-off. I hope trade-off is nothing but making a balance between a generalized model. Okay, we are making a generalized model here. Moving further, so what is a bias? Nothing. So bias is a error caused by simplifying assumptions in your learning algorithm. Okay, what it is? It is nothing but simply we can say that bias is the error. Bias nothing but it is an error caused by simplifying assumptions in the learning algorithm. Whatever a machine learning algo you are applying, there may be certain assumptions will be there. So these are the assumptions which you are take care of there. What it measures? How far your particular model average prediction is from the true value. This is an important line which I have already marked you in the separate section. if you forgot everything of the bias, but you have still remember this, you can relate the things that what is the bias can reflect how far the model's average prediction, how far your model average prediction is from the true value. For example, true value is 2, but your model prediction is 2.8, 3.5. So how much variation will be there? Okay, 0.8 variation will be there. Here you will find that approximately 1.5 variation will be there. So this is your basically the bias. Okay, how far the average performance for a model average prediction is from the true value. Okay, that is your known as bias. So a high bias model pays very little attention to the training data. If your bias is so high, that means prediction, average prediction is from the true value. If the average prediction is too high than the true value, then your bias is too high. That means that can ignore very little attention to the training data. If you are giving it to training some training data, then what it can do, it can provide a very little attention to that and oversimplifies the model. In that case, what's your model can become? It will oversimplify your model. So how they see, here are the 2-3 concepts. Number one, what is a bias? It is nothing but the difference. We can say that the average prediction, how far is your average prediction from your true value. If that particular value is too far, for example, here you will find that 0.8 will be there, here 1.5 will be there. That means 1.5 is a higher bias. That means very little attention to the training data will be given in the second case and oversimplify your model. That's why some basic training data will be neglected in that case, in the case of the high bias. Okay, so I hope the biasing will be the biasing concept is clear, that what is a bias? It is nothing but is the error caused by simplifying assumptions in the learning algorithm. What exactly you need to be keep in the mind, that how far the model's average prediction is far from your true value, and if high bias will be there, that means it provides a very little attention to the training data. That means oversimplify the model. Here we have given a particular example of this scenario. I hope public data, we have taken a particular data from this particular site. Okay, you can go and also review that particular article as well. Here you can found a briefing I'm providing. If bias is too high, then what will happen? So there is a model which can predict that a particular criminal is criminal or not. Okay, so for example, this Brish Boran is a girl who can only stroll a cycle, but he is a very well-known culprit there. Okay, so but what your model, since high biasing will be there, model will basically think based on the color. It is a white British person and he is a black lady. So what it provide the high risk 8. Why? Only because of the high biasing will be there. High biasing due to the color variation. She can only stole a little cycle, but it can rob a particular bank, we can say. So in this particular article, you have seen that this low risk will be model. What model will provide? It will be the low risk through that particular particular person, but there is a high risk. Why? Because of the high biasing. High biasing. Why it is done? Because of the color variation. Okay, these two person, one is a white person, one is a black lady. So what they can what the model can predict, it is a wrong assumptions. Okay, so this basically things will be occurred due to the high biasing. So we need to be neglect these type of things. Always keep in the mind, we need to be reduce the biasing in your particular model. But if you reduce the biasing, then variance will be become high. So how you can manage that, we can see in this particular session, that how the trade-off can be achieved for your particular machine learning task. So example of high bias models. So the simple linear regression on highly nonlinear data, it can always provide a high biasing. Then very shallow decision tree if you can make, then again the high biasing will be there. KNN with the large K if you can provide, then also it will provide a high biasing. So if someone asks you about provide some examples on how high biasing will be done, so we can say that the simple linear regression on the high non-linear data, very shallow decision tree, and the KNN with the very low large K values. Visualization. So high biasing, if I can say, so predictions are consistently wrong will be there. If high biasing will be there, that means predictions are consistently wrong. Here you can see that in this case, prediction is wrong. High risk will be provided to this particular lady who can just simply stole a particular bicycle, whereas low risk will be provided to this particular person who can rob the particular bank. So predictions are consistently wrong. Then model predictions are far from actual values. Definitely, if the biasings are too high, since how far your, as we have already discussed, what bias reflect, how far the average is from, average performance is from true value. Okay, so you can see here model predictions are far from the actual value in this particular case. Now, mathematical intuition, just simple example I have given here. So suppose the true relationships are in a non-linear we have. Okay, true relationships is non-linear, that is y is equal to the x square e. So here is a quadratic x square plus e. So this is basically a quadratic, but what we fit, we are fitting here by y equals to the ax plus b, which is a linear. So initially we have a quadratic, but we are fitting it by the linear. That means a linear model cannot capture the curvature, because you already know the quadratic equation has the curvature like this, and the linear model looks like this. So the linear model cannot capture the curvatures which are present in the quadratic equation. So this systematic error is the bias in your particular example. I hope you are able to understand it mathematically as well, that we have a quadratic and we are fitted with the linear model. So their linear model definitely do not predict the quadratic curvatures there. That's why we can say that a systematic error or the bias will be present in your particular model. Moving further, I have given the particular same quadratic and the linear example. So here you will find I provide the model type here with the high biasing. If I can provide the high biasing will be there. So you will find the high bias new data if you can enter there. So high bias, the model is too simple, that is underfitting will be there. That is, it ignores the underlying trend and makes the poor predictions on both the training and the new data. If I providing a good fit, why it is good fit? Because the model captures the parabolic pattern. Here you will find it predicts this particular pattern, but here you will find the model also predict the quadratic pattern. Why? Because it is a good fit. Model type I am providing the good fit. If I providing the model fit with very high variance, in the upcoming slides you will find what is the implications of the high variance. Here I have put a slide. Why? A model is too complex, that is overfitting will be there. You will see that this type of graphs will become overfitting will be there. It cannot predict that it is a quadratic. You cannot make an equation of this particular graph, okay, because it is neither quadratic nor a linear. It is something other complex equation you need to be make. So why? Because it memorizes noise and the outliers which are present and make a error predictions will be there. Now, examples of high variance models, I have added a particular slide here for the high variance so that you can learn the examples of the bias as well as the variance together. So deep decision trees provides a high variance. High degree polynomial regression provides a high variance. KNN with very small k. If you provide a very high k, then it is a high bias. If you can provide a very low k, then it provides a become an example of the high variance. Now, what exactly the variance it is? So variance is nothing but can measure how much a model can change when trained on different data set. How variance measures what? How much the model changes, when trained on the different data set. When you can train your particular model on the different data set, then how your particular model can be changed and how your outputs can be changed can be reflected by the variance. Okay, so high variance model learns training data too well. What it can do? It can learn the training data too well. Includes noise and the fluctuations also. What it can do? It can also include the noise as well as the fluctuations. Okay, so what variance can do? Variance measures model changes when the trained on a different data set, and if the high variance will be there, that means your it learns the training data too well. Okay, what it can do, it can learn the training data too well. Next, include the noise and the fluctuations also. Then the characteristics of the high variance, that nothing but the overfits the data. What it can do, it can overfits your data. Next, it can excellent training accuracy also, poor test accuracy, and the sensitive to the small changes in your data. So what are the characteristics of the high variance? Overfit the data, excellent training accuracy, poor test accuracy, and sensitive to the small changes in your data as well. Moving further, what is the mathematical intuition which is present here? So if different training data sets produce drastically different models, variance is too high. Okay, keep in the mind, if your training data sets, if different training data sets produce drastically different models, okay, if you have a different training data set and it can provides a drastic different models, then the variance is too high, we can say. Examples are data set 1, model prediction is the curve A, data set 2, that is model prediction, we have the curve B. So large change means large variance will be there. If something is large changes you can occur in, you can see in your model, then you will find that high variance will be there. So there is a basic thing, underfitting and the overfitting difference table we have provided here, where bias, if I can say, if bias we can say, so in the case of the underfitting it is high, in the case of overfitting bias is low. With respect to the variance, it is totally opposite. If it is underfitting, then it is low, and it is overfitting, then it is high. Multiple time it is asked in the interviews. Most of the time, you must have to remember this important table. Training error is high in the case of underfitting, whereas it is very low in the case of overfitting. Test error definitely is high in the underfitting. Whenever bias is high, test error is high. Okay, then it is overfitting, it is too high. Model complexity is too simple. There we can say that overfitting, it is too complex. Okay, so these are the basic table of underfitting and the overfitting you must have to remember. Now come to the exact thing. I hope you are able to understand what is a bias, you are able to understand what is a variance. Now comes on the bias variance trade-off. Okay, so if bias is too low, or we can say that too high, so reducing the bias usually increase your variance, and reducing your variance usually increase your bias. So what exactly you need to do? You need to be balance both of them. So this is basically a trade-off, bias variance trade-off. If bias is too high and variance is too high, and you need to be balance both of them, then that particular thing is known as a trade-off. You can see here as well, this red line reflect your variance, this green reflect your bias. See here, if variance is low, bias is high. If you increase the bias, variance, bias will reduce. If you increase variance too high, bias will too low. So you make a basic, we can say that, a point of trade-off between them. These are your training error, these are your test error. So what you need to be do here, so test error forms a U-shaped curve here. You will find that test error, what type of shape curve you can say, a U-shaped curve will be found. Optimal complexity lie at the minimum test table. So where is the optimal complexity lie? The minimum test level, the optimal, we can say just simply complexity will lie. So what exactly the trade-off? Trade-off is nothing but you need to be reduce the bias and the variance in such a manner that there may be the balance between both of them. Then how can we reduce that? A big question comes in your mind. So there is a simple thing. So to reduce bias, how you can reduce? There are certain parameters you need to be keep in the mind. Must remember these things. Okay, this video basically a conceptual video, a more lengthy video. Why it's become? Because it is contains lot of things there. Okay, bias will be there. If you do not understand the concept of bias, you are unable to understand the trade-off thing. If you are unable to understand the concept of variance, you are unable to understand the concept of trade-off between bias and the variance. Okay, so this must be remember that first you need to be understand the bias. I hope you need to be understand the variance. Then you need to become on the bias variance trade-off. Okay, now comes how this to reduce the bias. Okay, so there are certain factors. Number one, increase the model complexity. If you can increase the particular model complexity, then definitely your bias will be reduced. Add more features in your particular model, then definitely your bias will be reduced. Use non-linear models. Reduce regularization, train longer. Okay, if you train it longer, then these are the simple things through which you can found your particular bias will be reduced. So reducing a bias can be done by increase the model complexity, add more features, use nonlinear model, reduce the regularization and train the it longer. How to reduce the variance? Okay, now how you will reduce your particular variance? The simple thing is by collect more training data. These are the things you must have to be remember. रट्टाफिकेशन करना पड़ेगा इस केस में आपको. ओके, अदरवाइज ये दिमाग में नहीं रहेगी, या मल्टीपल क्वेश्चंस करोगे तो डेफिनेटली माइंड में सेट होती जाएगी. तो ये रटना पड़ेगा. गेट में भी कई क्वेश्चंस आएंगे, एमसीक्यूज आ सकते हैं जिसमें ये चीजें पूछी जा सकती है कि हाउ टू रिड्यूस द वेरियंस, हाउ टू रिड्यूस द वाइस, अगर थियोरेटिकल क्वेश्चन इसके ऊपर बनता है तो. सो ये सारी चीजें आपको पता होनी चाहिए. बेसिक से फंडेज हैं ये. ओके, स्टूडेंट्स आर अनेबल टू रिकॉल दीज थिंग्स एट द टाइम ऑफ द एग्जामिनेशन. वी हैव सीन मल्टीपल टाइम. सो ये बहुत बेसिक चीज है बट आपको रिकॉल नहीं हो पाती. ठीक है, आपको एक दो फैक्टर्स याद होते हैं, बाकी याद ही नहीं रहते, और गेट वहीं से पूछता है जहां से आपको चीजें भूलना आप स्टार्ट करते हो. ओके, सो कलेक्ट मोर ट्रेनिंग डेटा हियर if you want to reduce your variance. Use simpler model, apply the regularization, feature selection will be there, cross validation is a technique through which you can reduce your variance, pruning will be there, and sampling methods will also be there. There are most commonly a question which is asked in the interview, that how does regularization helps in reducing your variance? So just simply reduce variance by penetralizing the complexity. I hope we have already done the regularization thing in the earlier sessions as well. So you can just see that L1, L2 regularization and you can easily understand that what is the penetralizing mean. Okay, how you can penalize the things in your regularization technique. So that's all for your complete session of this bias variance trade-off. I hope you are able to understand that what exactly the bias and the variance. So I am just recalling once again so that you can reconnect the things. Okay, so I hope we have started with the Bais variance trade-off things. Just keep in the mind that model generalization will be there. What is the generalization? Good performance or the unseen data we have. Then we need to be proceed with what exactly your ML model looks. Your ML model is just good ML model means what is the optimal model means. Then this balances is achieved using these particular techniques, that proper model selections will be there. Regularization, why we have added this particular picture? Because it makes a balance. Okay, again and again, whenever a trade-off comes in your mind, you must have to be remember these pictures, these slides come in your mind when in the interview as well as in your examination, that this makes a balance. That's why we have added this particular thing. So whenever a bias variance trade-off comes into the picture, you have to be keep in the mind the term balance of the bias and the variance. Okay, so proper model selection, regularization, cross validation, sufficient data, and the ensemble learning will be there. Trade-off, we have already seen unfiltered data. The goal of the machine learning is to build a model that generalize the unseen data which is present. And this equation is the important. You must have to remember. Most of the examination, you have seen this, and a lot of things can be easily solved. That is bias square plus error can be make like this: bias square plus variance plus irreducible error. What is a bias and what is a variance? So this is your bias, that is how far your model average prediction is from the true value. Then we have seen this particular example. Then high bias examples we have seen. See KNN with very large K, and in the high variance we have seen KNN with the low K. Just opposite of that. Visualization part, we have seen this particular mathematical intuition basic example we have taken, where we can see that if quadratic problem cannot be solved by the linear generalization. Okay, so you need to be make a trade-off of that. Then high variance examples, see KNN with very small k will makes your high variance. These things you must have to remember. What are the variance? Measure of how much a model the model changes when they're trained on different data sets. Characteristics of the high variance we have seen, that overfits the data, excellent training accuracy, poor test accuracy, and the sensitivity to the small changes. Mathematical intuition, that is large change becomes make your large or the high variance will be there. These table must be rememberable. Then what is the trade-off? Just simple thing, that is you must have to be balance both of them. हम ये एक ही स्लाइड में बस पढ़ा के आपको 5 मिनट में वीडियो कवर कर सकते हैं, बट वो पूरा का पूरा वीडियो इसलिए है ताकि आप बायस को समझ पाए. हाई बायस कब कब हो सकता है, व्हाट आर द कैरेक्टरिस्टिक्स ऑफ द हाई बायस, व्हाट आर द कैरेक्टरिस्टिक्स ऑफ द हाई वेरिएंस, what are the features of the high variance, how high variance affects your model, what are the examples of the high variance, ये सारे हमने देखे, इन सबको क्लब किया, फिर हमने ट्रेड ऑफ पढ़ा. अदरवाइज 5 मिनट का कंसेप्ट है ट्रेड ऑफ. Simply you need to be balanced between both. What one is a bias and second one is a वेरियंस. यूनिवर्सिटी एग्जामिनेशन में आप ऐसे डायग्राम्स भी बना के आ सकते हो अगर यूनिवर्सिटी एग्जामिनेशन को आप देख रहे हैं तो. Okay, so that's it. How to reduce bias? These are the few things we 5 techniques we have think that you can reduce the bias. These are the 5 things through which you can reduce your particular variance. Okay, this how all we have to be studied in this particular session, that what is the bias and the variance trade-off. I hope you all are able to understand these things, that what is exactly this particular concepts generalizes you and what exactly this concept will train you. Okay, so thank you so much. Have a nice day, students. Take care. We will meet in the next session, in the upcoming session with the new concept. Have a nice day. Take care.